I wanted to post a review for the test that we will have on Thursday. So if you've been doing the work and maybe on your own you've been just reviewing the things that are under the content link, you should be in pretty good shape. I plan to make it another multiple choice test in a similar format to the quizzes. You may see questions from the syllabus quiz. You may see questions from the other two quizzes. You should actually be able to go into your attempts on the other two quizzes. Now that you've taken them, you should be able to go in and pull them up by clicking on each attempt and see the questions, see your answers, and see which ones you got wrong so that you can figure out the right answer and study from those. Now, where I am focusing as far as the material to study is I'm in the content tab. So of course you can review the syllabus. You may see a couple questions on that. The other thing is I'm really focusing on the terms here on these videos. Now if you click them within the content area, I've got to kind of figure out why you get this error message. Oh, actually, I think I just need to set it up so that it opens in a separate window. But you may see something like this, and then you should be able to click here to get the video to work. But if not, and this is just this little thing that pops up for me, you won't get that. You can always sort of hover over a link, right-click it, and then do open link in a new tab, and then you won't have any issues with the URL. So you need to remember that, and this is really important, we're going to be working with the CPU. That's what we're going to be sending our instructions to when we are writing code. So you need to think about what the CPU stands for. You need to remember Central Processing Unit. It is the brain of the computer. That is what we're going to send our instructions to when we write code. The computer is really a dumb machine. It will do only what you tell it, and it will do exactly what you tell it, even if you make a mistake in what you tell it to do. It's not smart enough to infer or figure out what you meant to say. It does literally what you tell it. And that is all handled through the CPU. It performs data processing, meaning if we tell it to open a file, close a file, write data to a file, it's going to run programs. It's going to do logical comparisons, which we call if statements. We can loop or repeat code without writing it 100 times. We can write it once and tell the CPU to repeat it 100 times. And it basically controls the input, the output, the keyboard, sending stuff to the printer. All of that stuff is handled through the brain of the computer, the CPU. It's very important. That's why when you purchase a computer, one of the most important things to look at are the specifications of the CPU. How fast is it? Can it do multitasking or multi-threading? All of that stuff. So I would urge you to do research on your own about different CPUs when you are buying a computer or laptop. Now the CPU is actually three parts that together we call the CPU. The memory unit, the control unit, and the arithmetic logic unit. So the memory unit is going to store instructions. It's going to store our program temporarily in RAM, random access memory, memory that goes away when you turn the computer off. So we turn the computer on, our program's not in memory, we'll fire up Visual Studio, we'll tell it to run the program, it will take the program, put it into the CPU's memory, and start executing the commands in our program. So the memory, the memory unit can store the program. It can store intermediate results. If we're going to add 5 or 6 numbers and then multiply something and divide something, we're going to manipulate the memory of the CPU. So you actually as a programmer have the power to directly manipulate the memory of your computer. And so intermediate results, if I'm doing a formula that requires multiple steps and I need to store the first answer, and then I need to take the first answer and do something else to it to get another answer. Then I need to manipulate it again to get the final answer. For example, if I were computing Easter Sunday, there's a whole involved algorithm that helps you determine what date Easter Sunday falls on every year. That's why there's so much variability in it. It's not like July 4th where it falls on the same day every year. There is sorry, still got a cough. There's probably 10 or 13 steps to figure that out, and you have to do some complex math in each step. So you store each result in memory until you get to the final answer so you can keep manipulating it. And we do this through something called a variable. A variable gives us a way to give a memory location, say an 8-bit unit of memory, a name so we can reference it. We'll find out about that later. It supplies information to other parts of the computer when needed. It is really, when we talk about the memory unit in the CPU, we're talking about the random access memory, not your hard drive, not permanent memory, but random access memory that goes away. You lose the data in it if you don't save it somewhere on the hard drive when you turn the computer off, or if the power goes off unexpectedly, the battery dies on your computer, and you haven't taken things out of RAM, like you've opened Notepad, you've been typing in Notepad. Notepad does not auto-save like Word does now. And if that all is in RAM until you save it and write it to the hard drive. So if the computer loses power and you have not saved something, say in Notepad, you lose it. No way to recover it. And again, you can read all of this about the size, the power, the capacity, all of that. Now we're going to move on to the control unit. Control unit controls the operations of the computer but does not carry out any actual data processing. So it will move data around on the computer, say from RAM to writing it to the hard drive. It can obtain the instructions from memory and interpret them. So we load a computer into the memory unit with the instructions, and the control unit actually one by one executes those instructions for us. And then it might the program might say write this to a file on the hard drive, and the control unit will direct it to do that. More important to me is the arithmetic logic unit. This is where, if I'm doing mathematical calculations, or if I'm even sorting words alphabetically, if I am doing anything that requires comparison, like an if statement, if I am telling it, here's a line of code and I want you to repeat it 100 times, all of this happens with the arithmetic logic unit. So it's got a logic section, and it says right here, it does comparisons. We're going to see how that works when we do if statements. The arithmetic section does the math. And we'll find out in programming that math follows the order of operations that you have learned all through school. PEMDAS, please excuse my dear Aunt Sally. That is the way that the computer, fortunately, does arithmetic, so we don't have to relearn a way to give it the precedence of multiplication and division over addition and subtraction, because it already understands that. It's been created to do that. So that's very important. I want you to focus on the CPU. I know there were some issues with the CPU video, so I'll try to avoid putting anything specific about that on the test. Input devices, pretty straightforward. Keyboard, mouse. Most of you may not have joysticks anymore because on your gaming systems you have those controllers, but back in the day on the Atari systems we had what was called a joystick. Scanners, tablets with the touch screens, a microphone, magnetic ink card reader. You probably have never seen one of these, but in the business world now, you have this thing, and it's sort of like shaped like a horseshoe. You feed a check through it. On the bottom of a check, if you've ever seen one, now that everybody's using debit cards, there is a MICR line, a magnetic ink line, that has the account number and the bank's routing number on it. And that is what the bank, that is what these little things that they have now at businesses, that's what, if you give a check to Walmart, they've got a MICR reader, and when they run the check through it, notice they always put it so that The very bottom of the check is all that's running through the scanner, and it actually reads the magnetic ink on the check and figures out your bank account and routing number. Optical character readers, like those little bar scanners, those personal scanners you can buy and run down a piece of paper, that's an input device. A barcode reader, like they use at the grocery store. All of those are input devices. Keyboard, of course, being the most common one. And I bring this up because when you write a program, the CPU works with the BIOS, the very lowest level programming that comes with the computer, that is saved in read-only memory, memory that the manufacturer writes to, that you cannot change, but that does not lose information. It's not your hard drive. It's just a tiny bit of information that the manufacturer writes information to before they send you the computer, and it has something called the BIOS, some very, very low-level programming languages that help the computer, the CPU, to understand when it starts up, this is a laptop that has a keyboard as the main input device, versus this is a tablet and the screen is the main input device. So this lower level read-only memory with the BIOS communicates with the CPU and helps it understand what the default input device is for your machine, and that's how the computer knows whether to expect input from the keyboard or from a touch screen, and so on. Alright, so here's just some stuff I will let you read. Of course, you know what a mouse is. There's an old-fashioned joystick, and it's got an example of each one of those. And you guys can read up on that, but expect to see that. Look, that's a really old-fashioned scanner there. Now they're on our printers. The Micker readers actually look a little different than this now. They're smaller. They're actually more horseshoe shaped, so the check kind of goes around in them. At least the ones that banks give to businesses, so they can convert your check more or less to an ATM card type transaction. So make sure you understand output devices. A screen is an output device, anything that displays information back to the user. So we've got the monitor. I call it a screen. They call it a monitor. Boy, that's an old one. We've got printers. Those are output devices. They can provide information back to the user. Dot matrix, that's back when computing history and daisy wheel, when we first started out, you really don't see those except on eBay anymore. So you're thinking more about today laser printers or inkjet printers. Those are the things you'll be most familiar with, but you need to know all of the terms on that page. And so I will let you continue on with these. The most important thing to realize is there are different types of memory. There's permanent memory or storage, such as a hard drive, a flash drive. It gets written to when the computer loses power. That data is still there. When you turn the computer back on, you can pull it back up and reference it. RAM is random access memory. It is temporary. You can manipulate it, but when the power goes off, anything in RAM is lost unless you specifically converted it to the actual memory on the hard drive or the USB by saving it, turning it into a file. ROM is the read-only memory that comes from the manufacturer with the very, very low-level instructions of that the computer needs just to start up, to even start up Windows, to get you to a point where you can interact with the computer. And you need to make sure you understand memory units and the motherboard, bits, bytes. A single unit is a bit, 8 bits together is a byte, and then you add up the bytes and you start getting, hard drives with so many gigs and all of that kind of stuff. So memory is also important when you're shopping for a computer. Not so much the hard drives anymore, those are inexpensive, come down in price, but the amount of RAM is very important. So when you're looking at a computer, the two most important things, CPU and the RAM. You need a lot of RAM nowadays, the more the better. Now, computing history, I've done videos on that. I've had you do a PowerPoint. So Abacus, Pascaline, all those devices that were covered in the lectures and that you did the research on for the PowerPoint are fair game. We will not have binary or HTML on this test, so it will primarily be what I've just covered on the terms and computing history. Multiple choice format, I will tell you, I will randomize the questions so you and the person you're sitting next to will not have the same question at the same time. I also randomize the answers on the test. And if I build a big enough test pool, I'll probably pull 20 questions, and you may or may not get the exact same questions as the person sitting next to you. So don't count on being able to glance over to somebody's computer